morning. Happy Wednesday. Welcome back. We'll take our quick look at the calendar before we start on page 18 in the packet. Today, we are moving right along, talking about ratio and proportion. And again, our very first quest is coming up on September 17th. It is not too early to start thinking about studying for that quest. It will be here 1 week from today. All right? Yes? Fiona. There is a practice quest in the packet. You have to go a few pages. Yeah, you have to just hunt around a little bit to find it. Yes, Lydia? Yeah, so see if anybody can find the sample quest problems. Looks like page 33. You guys go there real quick. So we're starting on page 18, but open to page 33 just for a moment. And on page 33, you will see the start of practice problems for quest number 1. Again, not too early to start preparing for this quest. It's happening 1 week from today. And you'll notice in the instructions at the top of page 13, it references YouTube videos. So I actually went through and made a video of me doing each of these problems. So like try the problems on your own. And if you get stuck or you don't know how to get the answer, there is an answer key in the packet, but I have full-blown solutions up on YouTube. Okay, just have to know how to find them. It's roughly the same length as this quest. Okay, so that's coming up 1 week from today. All right, so jumping back to page 18, we will start up at the top with there we go, with the daily summary. Can we start with Virginia? Thank you. Fiona, number 1. Okay, thank you. Number 2, Casey. Okay, so we just hit you with a couple of vocabulary words. A ratio is just a fraction. So this thing right over here is a ratio. This is also a ratio. If you have 2 ratios equal to each other, that's what we call a proportion. So this entire thing, that equation, is called the proportion. And you can see the equation is written here twice. We're going to solve the same problem in 2 different ways. You pick whichever one you like. A lot of people like to cross multiply when they solve a proportion. So what that means is that we look at the 2 things on that diagonal and we multiply them. 5 times x minus 1. We look at the 2 things on the other diagonal and we multiply them. 3 times 7. So that's why we call it cross multiplies. We're looking at the crosses, the diagonals. We're multiplying them. And what symbol goes in between? It's equals. This is how we cross multiply. You multiply the 2 diagonals and you make them equal. Now we're going to finish this and then I'm going to show you the other technique which I prefer better than this. You could distribute, you could divide by 5. I'll distribute. 5x minus 5 equals 21. Add the 5 to both sides. So 5x is 26. And then finally, divide both sides by 5. So we get x is 26 over 5. Okay, so that's one technique. Here's a technique that I prefer, even though it's going to take us like 1 step longer, but I think it's going to be more accurate. Here's what we're going to do. We're going to multiply both sides of this equation by both denominators. So I'm going to multiply this side by 7 and by 5, both denominators multiplied together. And if I multiply the left-hand side by 7 and 5, then I better right away multiply the right-hand side by 7 and 5. So first, can we agree that's something legal to do? As long as you do the same thing to both sides, we're fine. Now, instead of calling that 7 times 5 35, leave it as 7 times 5 and then immediately cancel. I see a 7 on the top, and I see a 7 on the bottom, and they cancel. And on the right-hand side, what cancels? The 5s. And so what I'm left with is 5 times x minus 1 equals 3 times 7. And do you recognize that equation? It's the same one that we got right over here from cross multiplying. So here's what I'm going to say. You can do whichever method you want, but I think the second method is far more reliable because it isn't just like this miracle thing that some teacher said, hey, cross multiplying works and that's how you solve proportions. It's something very legitimate. We're multiplying both sides by something concrete. As long as we do the same thing to both sides, we're okay. We cancel, and we're left with, oh gosh, that's what it looks like when you cross multiply. But cross multiply is just this like random technique that somebody says works, and we do it without really understanding it. But even worse than that, I think that cross multiplying, a lot of folks, when they cross multiply, they say, oh, I know I'm supposed to do 5x minus 1, and I know I'm supposed to do 7 and 3, but they end up putting a fraction line between them instead of an equals line between them. And it's because they don't understand what cross multiplying is really doing. And like it doesn't turn an equals into a fraction. It turns an equals into an equals. The other problem I have with cross multiplying is that once you get good at cross multiplying, you might kind of forget how to actually multiply two fractions. How do we multiply two fractions? Straight across. But if you do enough cross multiplying, you might start to think that you're supposed to do 3 times 7 and 2 times 4, and that's not right. So that's why I don't really like cross multiply. So I encourage the second one, but whatever you want to do is fine. Okay, one word problem, and then we'll start the activities. Can we go up here to Dan for number 3? Okay, thank you, Dan. So we've got to tackle this problem. We're given a ratio of female students to male students at GCC is 3 to 2. And the goal is to try to find out how many students at GCC are female. So when it comes to the first step, which is defining a variable, the question here is telling you what the variable should represent. It should represent how many students at GCC are female. Okay? That's what we're after. So we'll start with let x equal the number of female students. Okay, now we're going to start with our proportion. First ratio is this 3 to 2. So I'm going to write that as a fraction, 3 over 2. And then I'm going to put some words here. You don't have to put these words, but I think they help. Does that 3 represent male or female? It's female. 3 to 2, the word female came first, which means female is the first number, male is the second number. So you got to pay attention to the order. So the numerator represents number of females, and the denominator represents number of males. And I'm going to put equals. I'm going to make it equal to some other fraction. Our variable is about to come in here. Does the variable x go top or bottom? Top, because we said x is the number of females, and the females number was up on top of the fraction. So definitely x is up here. So here's the tricky part, is filling in that last blank. It's supposed to represent the number of males. That's what we got to put down there, something to represent the total number of males at GCC. So tempting is to just call it a y, but that you can't solve that equation. It's got too many variables in it. 2,000 minus x. That's what we put right there. 2,000 minus x is the number of males, right? Because the 2,000 was the total of all students, which was the males plus the females And so definitely if we take the 2,000 and subtract off the females, we will be left with the males. And so that's the biggest trick for this one, is to think carefully about how to introduce the number of males without a new variable. Lydia. Mm-hmm. Yeah, 3x and 2x. So like this? Yes, okay. So Lydia's got a perfectly good way to solve this problem. 3x plus 2x equals 2,000 will solve the problem, although in this case, x does not represent the number of females. It's a different x that she has defined there. If you like thinking of it in that way, yeah, as opposed to x is the number of females, x is just some underlying unit, some underlying multiplier. We know 3 and 2 are important. We got to multiply both 3 and 2 by some number, and it's going to build up to give us the right thing. You're perfectly welcome to use that equation, you, Lydia, and you, anybody else. If you prefer the fraction, then use the fraction. There are many ways to solve proportions. Okay, let's finish solving this blue equation here. So remember, we could either cross multiply, which I will not do, or we could multiply both sides by both denominators. So I think I need some space. So I'm just going to copy that again. And then we're going to multiply both sides by both denominators. So we're multiplying by 2 and also 2,000 minus x in parentheses. Both sides by both denominators. So we put that on the left. Right away, we also put it on the right. Okay, it might be tempting to take this 2 and distribute it. It's not wrong, but it's not going to help you. The point of putting those things up there was to immediately cancel them, not to do algebra on them. So what cancels on the left? The 2's. 2 on the bottom cancels with the 2 on top. If you had distributed the 2, you might not see that the 2 on the bottom cancels. So don't distribute. On the right-hand side, what cancels? 2,000 minus x. That entire thing, that whole thing there is an exact copy of this whole thing here. So they just both go away. And if you multiply both sides by both denominators, you will get rid of all the denominators. That's the idea. So it's really just carefully reading what remains. 2,000 minus x is multiplied by what? By the 3. Equals, and then on the right-hand side, x is multiplied by 2. And that's it. So the fractions go away when you multiply both sides by both denominators. Okay, there's still a little bit of work to do here, but at least we've gotten rid of the fractions. So we are going to distribute that 3. So it's 6,000 minus 3x equals 2x. The tricky part about this equation, or the thing that dictates what we have to do, is what characteristic of that equation? Variable on both sides. That's exactly it. That's what you have to recognize. You know, like if you just see 2x equals, you might be tempted to divide by 2, and that's oftentimes fine. But there's x's on the other side. It's not, you're not there yet. You got to get all the x's onto the same side first. So how about we add that 3x to both sides so that we can collect the x's over on the right. So the left-hand side, we just have 6,000. Right-hand side, we have 5x. And then finally, we get to divide by that number. So divide by 5. We get x is 1,200. Okay, so the stuff that we're working on today is setting up the proportion, which is often harder than solving the proportion, okay? The activity consists of only 3 problems. They are all word problems, so they'll take a little bit of time. But the quicker you get through those 3, the quicker you get to start on your homework, which I expect you will be able to make a big push on during class today. So jump in. I will help if I can.